Avi Loeb just released new information about 3I Atlas today, and amateur astronomers around the world are capturing the clearest images we've ever seen of this object. What we're witnessing on November 16th and 17th is once again triggering major debates about the physics of this comet, because nothing about its behavior is normal. So in this video, I'm going to break down exactly what's going on with 3I Atlas right now, factually, clearly, and without any hype. Back in late October, 3I Atlas disappeared behind the sun from our point of view. For nearly 2 weeks, ground-based telescopes couldn't see it at all. Then on November 6th, the Virtual Telescope project finally captured the first good images. The comet was only 12 degrees above the horizon, extremely low, but even from that difficult angle, we could start to see an ion tail forming. By November 9th, the geometry improved and the tail became far more visible. As a comet orbits the sun, the angle we view it from changes dramatically. Before perihelion, its tail was mostly hidden behind the nucleus from our line of sight. But now that Atlas is moving into the morning sky, the tail is spreading out, becoming sharper, longer, and much easier to observe. Then came November 11th. New images showed the ion tail stretching nearly 1 million miles across the sky, pointing northeast, exactly the direction we'd expect, since that's away from the Sunday. But there was something else in that image, a faint anti-tail pointing toward the Sunday. 4 days later, on November 15th, an astronomer in Thailand captured an even clearer shot showing both the normal tail and a bright, razor-sharp anti-tail at the same time. And on November 16th, we captured what may be the best image yet. A stunning view of the bright central coma, the main tail sweeping away from the sun, and multiple sunward-facing jets. The detail is incredible. Here's why this is so strange. A comet's tail always points away from the sun because of solar wind, a constant blast of charged particles traveling at over 800,000 miles per hour. It's basically a cosmic leaf blower forcing dust and gas behind the comet. But an anti-tail? That's extremely rare. Instead of pointing away from the sun, it points toward it. We have seen anti-tails before, but they're usually optical illusions created by large dust particles falling behind the comet as it moves. From certain angles, the tail appears to angle toward the sun, but it's not real. This time, that explanation doesn't work. Telescopes from multiple countries, different angles, and different conditions are all seeing the same thing. The anti-tail is real. So the big question becomes, what kind of material is forming this structure, and why isn't it being blown away by the solar wind? We currently have 3 possible explanations, and all 3 have serious problems. The first explanation is that the anti-tail is made of very large, very heavy dust particles. For the math to work, these particles need to be about 100 micrometers in radius, far bigger than typical comet dust, which is only about 1 micrometer. A 100 micrometer particle is roughly 1 million times more massive than a normal dust grain. Being that heavy, they wouldn't get pushed away by the solar wind, and instead would fall behind the comet, forming a sunward-facing anti-tail. But here's the problem. To produce the brightness we're seeing, the comet would need to eject 100 times more mass than usual. And we already know 3I Atlas didn't shrink after perihelion, meaning it's not losing mass at anywhere near the required rate. The numbers simply don't add up. The second explanation is that maybe the anti-tail isn't dust at all. Maybe it's made of chunks of ice. When ice is ejected from a comet and exposed to direct sunlight, it begins to sublimate immediately, turning into gas almost instantly. When ice is ejected from a comet and exposed to direct sunlight, it sublimates almost instantly. It turns into gas, sprays outward, and becomes part of the normal cometary tail. But in the case of 3I Atlas, the anti-tail structure looks stable. It's not fading or dispersing the way sublimating ice should. For ice to form a persistent sunward-pointing feature, the chunks would have to be extremely large, far larger than anything we've ever seen being thrown off a comet. And that leads to the second problem. Large chunks of ice shouldn't survive this close to the sun in the first place. They'd vaporize long before forming such a sharp, defined anti-tail. This explanation doesn't fit the data any better than the oversized dust grain hypothesis. That brings us to the third explanation, the strangest one. Some astronomers have suggested the anti-tail might be created by jets erupting from the comet's surface. These jets could spray material in specific directions, forming structures that appear to point toward the Sunday. If the comet is rotating and releasing material unevenly, it could generate multiple tail-like features at once. And we are seeing jets in the latest images. That part is real. But this theory also runs into major issues. Jets should still be affected by solar wind. They might change direction slightly or curve, but they shouldn't create a clean, rigid line pointing directly toward the Sunday. For that to happen, the material must be either extremely heavy or completely unaffected by charged particles, and neither scenario fits anything we've observed in a typical comet. The images from November 16th and 17th show an object behaving in ways that do not match standard comet physics. We're looking at a structure that is not supposed to exist, and yet multiple telescopes across the planet are confirming it. Whatever 3I Atlas is, it's refusing to behave like a comet, and the universe doesn't make mistakes. If this object continues breaking the rules of physics, then we're not just witnessing a comet, we're witnessing something we've never seen before. And for the first time, we might have to admit we don't know what's moving through our solar system.